All right. Even better. That individual user's permission will be taken into account. So if I execute code on that cluster, and I have like user level permission that only I have and no other user, I will still be able to get that data. If I'm a user who is there in multiple groups, I will get the permission of each of my groups. It's completely additive. All right. And this architecture is also used for serverless notebooks and serverless jobs. And it's also used if you have a UC-enabled SQL warehouse. This is also the architecture that we have. We have a second exit mode, the dedicated one. Scott will later tell you all about this. But just a quick overview. This one is an access mode where you dedicate a compute to a single user or a single group. And the key message is, if you do this, you get privileged machine access, meaning you can run the full unrestricted Spark API, including things like RDD APIs. But the fine-grained access control is boiled down to the single user or the single group that you assigned or dedicated your cluster to. Scott will, again, tell you more about this, but that's the general overview of what you have. Now, how is this relevant for you? If you use serverless, not at all. It's configuration less for you. We use the standard access mode for this one. You don't have to do anything. If you're using normal clusters, you can, the UI experience looks like follow. If you create a compute, there is an advanced setting that you can set. And there, by default, it is in what we call the auto mode. By auto mode, will determine what is the best access mode for you based on the other configuration settings that you did for your cluster. So if you're picking, for instance, an older version of Databricks runtime, we sometimes might recommend that you start with the dedicated access mode. But when you move to a newer one, we mostly will guide you in the auto mode to the standard access mode because it has more features. All right. You can do the same in the API. There is a field called data security mode. We recommend that you set that to the auto mode as well. This is equivalent to the UI. And if you want to do that at scale, we recommend that you use cluster policies to set this for all your clusters. All right. So that's the primer on UC Compute. Let's jump into standard clusters and serverless. Let's recall that we have two goals here for secure and efficient compute. We want to make sure that users are separated from each other and from the Spark engine to prevent the overfetching problem. We achieved this using what we call Lakeguard, which is a bunch of technologies that enforce the governance at the runtime layer. And on the Spark driver, what we do is that we essentially isolate the Spark driver and each user session on that machine. So each notebook and job and client code that you're running is completely separated from other users and from the driver, using a combination of a sandbox technique for the workloads itself and Spark Connect so that your notebook can still use Spark code. All right. And we did something similar on the executors, because on executors you are still able to run user-provided code, and we have to ensure that the same applies for the user-defined code, that cannot escape to the Spark driver and not like see anything that another user runs, or see something that's going on in the Spark executor JVM. So we use the sandbox isolation technique for this as well. All right. So what does it get us in terms of new features and workloads? So there are three things that I want to talk about today. The first one is machine learning. With Databricks runtime 16.4, you can already run a couple of machine learning workloads on a standard cluster. So what you can do is, and it's included out of the box with Databricks runtime, is you can use scikit-learn, and you can use MLflow for your MLOps and your tracking experiments. And on top of this, what is provided in Databricks runtime, you can install PyTorch, XGBoost, TensorFlow on top of it. All of this will run in single node mode, meaning that it will run on the driver only. It will not be distributed to the executors. And now new with DBR17, will also allow you to run Spark ML on a Databricks UC standard cluster. It will be both single node or distributed, so it will make use of the executors. And you don't have to install anything. It is bundled in Databricks runtime, not even the ML version of it, just a plain one. If you want to use GPUs, our recommendation is that you try out the new serverless GPU compute that we have in serverless. It essentially allows you to run your GPU workloads on serverless using the same architecture. All right. The second important thing that I want to talk about is structured streaming. So up until recently, structured streaming was something that was not fully supported in standard clusters. That is because it requires the same user isolation that we need for UDFs, but now for the driver with a couple of more technical challenges to overcome. But since the most recent DBR version 16.4, we have the full streaming API support. So including user-defined code or user-provided code in terms of for each batch, flatmap group with state, transform with state and pandas. So this is also the code example here. As you see, there is a function that we define here, which is our for each batch function, and we provide this here. And when you do this, even though this is user code that is actually executed by Spark, and that also does some Spark calls within it, it's all isolated using a combination of the UDF sandboxing on the executors and the Spark Connect protocol. All right. Finally, last thing I want to talk about today for standard clusters is how you can connect to external cloud services. You might be familiar with the concept that we had before, where you could attach instance profiles or service principals to your cluster, and then every user gets essentially permissions that is part of that instance profile. This is something that wouldn't work with the UC governance model in UC because each user might have different permissions. So we added a replacement for this one, which we believe is better, which we call UC service credentials. And UC service credentials allow you to authenticate with cloud services using the same mechanism for short-lived credentials as we have with instance profiles. Plus, you get access to you can govern the access to those service credentials using Unity Catalog. So you can essentially, if you look at the code, this is just normal Boto 3 AWS Cloud SDK code, and you provide a name for service credentials. Let's call it my secrets manager credential. And if I, as a user, execute this code, Unity Catalog will check whether I actually have permission to use this credential. And if I do so, under the hood, Unity Catalog will get short-lived credential and use this one to authenticate with the Boto 3 session to access Secrets Manager. All right. This is a replacement for instance profiles or service principals or Google Service accounts. It's available on all UC clusters. It's available for Delta Live table pipelines. It's available also for user-defined functions on UC-enabled SQL warehouses. All right. That's how it works on the standard cluster, and that's what's new for the standard cluster. And I'll hand it over to Scott to tell you how all of this works on a dedicated one.
Hopefully, okay, yep, my mic's hot. Thank you. Thanks, Jacob. So yeah, I'm just gonna talk a little bit about dedicated clusters or dedicated access mode assigned to a single entity. Essentially, shorthand, we call them dedicated clusters, although that's not the formal product name. So before I dive into it though, how they, kind of how to create them, how they work, some of the use cases, I wanna start by talking about like some of the reasons you might use them. So hopefully, we can kind of go through and convince, like most of these use cases will hopefully work on serverless or standard, but in some certain ones you still need to use dedicated. So we'll go into it here. So first and foremost, the kind of last remaining language that doesn't work on serverless or standard is R. So the R programming language. So if you're using R, you're going to need to use dedicated access mode. If you are using distributed ML aside from Spark ML, which Jacob just talked about, like so distributed PyTorch or distributed TensorFlow or distributed XGBoost, these are all still only supported on dedicated access mode. So you'll need to use that. If you're using the Docker container service, so basically you're providing a customized image that we then combine with our DB runtime, and you're using that to deploy your clusters, that's still only supported with dedicated access mode. There are a handful of Spark APIs that are not yet supported on standard and serverless, and then there's also a few kind of corner cases for streaming data sources and streaming data source configurations that are not yet supported on serverless or standard. So definitely recommend taking a look at we have a documentation page that's like cluster access modes limitations that kind of goes through all of these kind of little corner cases. In general, This list at the top used to be a lot longer. Like even when I started here like 9 months ago, this list was quite a bit longer. So some of the ones that are, if you've been with Databricks for a while, you might not necessarily be keeping up with all the news, but like some of the things that are no longer reasons to use dedicated access mode, GPUs for one, we just recently announced the serverless GPU compute that Jakob mentioned earlier. It's in beta, you can try it out. You can get access to NVIDIA GPUs on using serverless compute. Scala is also now in GA, supported for standard clusters, and we're working to bring it to serverless cluster, or serverless as well, so serverless compute as well. So that's going to be coming soon also. So pretty soon Scala will work on standard and serverless. And then Spark submit jobs, that we now added a capability where you can just use a jar task instead. So if that's a use case that you have, you can use a jar task instead on a standard cluster and be fine. But again, there are some kind of nuances and corner cases and stuff that still remain. We're looking to close those as quickly as we can. If you have any other reasons or issues that prevent you from using standard or serverless, we'd definitely like to talk to you, help us prioritize the ones that are important to everybody to get all of this stuff working on serverless and standard. Cool. So now a little bit about how dedicated works, like what are the key characteristics. Like I think Jakob mentioned this earlier, it's kind of the full unrestricted Spark API access. So this is the close to the original kind of Spark concept, single user, single entity, single assigned principal entity that Jakob talked about earlier. And the way it works today is you either that authorizing principal is either a user or a group. So you can assign a dedicated cluster to a single user or to a single group, and all of the permissions for any activity that is executed or run on that dedicated cluster the permissions are scoped to that assigned authorizing principal. So no other permissions are honored. So if that our authorizing principal is a single user, for example, that single user's permissions will be used. If it's a group and I'm a group member, only that group's permissions are used, not my individual user's permissions. So that's just something to keep in mind. I'll get into some of the kind of nuances that brings about in a couple of slides. So in terms of how to create dedicated access mode clusters in the UX, Jakob already showed part of this, but it's essentially, instead of the auto mode, you pick manual, and also it's under the advanced settings kind of toward the bottom of the create compute UI. You click manual, select dedicated from the dropdown, and then you put in your authorizing principal essentially. So it's either a single user or a group. The bottom slide down here just kind of shows you, the bottom picture just kind of shows you if it's a group cluster, if you assign that dedicated cluster to a group, all of the group members automatically inherit, the group automatically inherits the can attach to, so all group members inherit that permission so they can attach to and use the group cluster. We do that automatically so you don't have to mess with that at all yourselves. Yeah, so then as far as like the behaviors I was talking about, like kind of about the specific permissions that are used, this is an example where for any of the Unity Catalog securables, so we're talking about tables, schemas, endpoints, models, connections, the various UC Unity Catalog securables, the permission of the authorizing principal is the only permission that's used. So if it's a group cluster, for example, and that group does not have permission to explicitly been granted permission to read a table, a select star on that table is going to fail. But as long as the group has permissions to it, it will work fine. So down below you see the example of like, all right, well, John Smith is a member of a group, but they maybe try to run a query on one of the tables, like a temp table they've created in their user schema, their personal Scratch schema or whatever. They try to run that select star from a group cluster that they're a member of. They're going to get the insufficient privileges permissions error. Most of the time, the error that you can get is something like insufficient permissions. Sometimes the error is not found simply for kind of better security practices. So just if you see not found, oftentimes it's a permissions issue. Just keep that in mind. Let's see. Also want to mention, this also applies if your users belong to multiple groups. only the group's permissions of the cluster that they're using are used. So even if they belong to other groups, if they're attached to and running a notebook against a group, a dedicated cluster assigned to group A, only group A's permissions are used, even if they also belong to like groups B, C, and D. So again, this is all, there's only a single authorizing principle that is used for dedicated clusters, whether that's a user or a group. So then also, this also applies to any Unity Catalog securables that are created from the group cluster or from the dedicated cluster. So essentially, any of those objects are going to be owned by the authorizing principal. So in this example, again, I use group clusters where I create a schema that if it doesn't exist, and assuming I'm running this on a group cluster, the marketing DS group is the name of the group that I assign that group clusters to. Then the owner of this object, of this new schema that I just created, is going to be the marketing DS group, not my individual user. So workspace objects in general work fairly similar. So if I just have an example here where I'd use dbfs to copy a file from like an example, a sample data set into my own group workspace folder that I created. Again, when you then pull that up and look in the UI, you'll see that the owner is the group, not the user of that file. So again, just workspace objects are mostly consistent with that. There are a few exceptions, such as if you use if you use like AutoML for like a regression or something like that. Some of the artifacts are created that belong to the user, and they belong to the user. They're kind of the workspace artifacts, but the stuff that actually gets executed by the runtime all belongs to the group. So, but we're working on kind of fixing all of those little the edge cases. So the audit logs for dedicated access mode clusters, because the authorizing principal is the entity that is used for all authorization, access, and permissions. We actually record both the authorizing principal and the user that actually was authenticated and actually executed the command. So so we have two different tags in the identity metadata column of the system access audit log. The run by is the authenticating principal, so single user or group, and then the run as is whoever the user was logged in as when they executed that command on the dedicated cluster. So both of those pieces of information are available in the audit logs, so that there's always a record of, hey, it was group cluster, this command to drop a table came from a group cluster, but it was actually run by so-and-so, so you can go yell at them for dropping a table that they shouldn't have. Let's see. Okay, yeah, and then Jakob kind of touched on this a little bit already, but just for dedicated access mode clusters, we still handle the securing the two kind of issues that Jakob mentioned. We still make sure that the security controls and governance of Unity Catalog are not bypassed by that. So essentially, for the fine-grained access control, which is the primary use case here that's relevant to group clusters, again, we do that fine-grained access control filtering off of the cluster in what we call the filtering service, so that the overfetched data never reaches the dedicated cluster, whether it's for a group or a user. So this solves the issue. Both of the issues that Jakob talked about as for securing the Lakeguard help us enforce on Spark. Right now, there's additional cost for the serverless running on the filtering service, so keep that in mind. If you're using fine-grained access control from dedicated access mode clusters, there'll be an additional serverless compute filtering cost. But then fine-grained access control also still supports both reads and writes. The writes are supported via merge into and append. So yeah, that's pretty much that. So pretty much done. As far as the content we have, we definitely want to open it up for questions, but hopefully this helped you all understand a little bit more about how we've taken Spark single use, kind of the way Spark is currently architected, provided additional isolation and protection and governance via Unity Catalog, via Unity Catalog Lakeguard. And yeah, if we have any questions from folks, we want to open it up, feel free to ask. We can come around with the microphone.